Okay, so I thought I'd go ahead and just make a video of this whole thing working. So anyway, here is the transistor-based H-bridge, and it is connected to the motor outputs of a servo. The only difference from the original schematic is that we have the comparator in between the two to properly adjust the output signals. Here's the schematic showing what I did. You can see the input thresholds are being set by a potentiometer right here. Okay, anyway, I also have the oscope hooked up. Channel 1 is connected to output what I'm going to call channel A on the servo, the one motor signal, and the second channel is connected to the output of the comparator. So we can now see how the servo signal is being modified. So right now it's actually on, but I have the output, I guess the output shaft of the servo is exactly neutral, so the pulse width it's receiving is exactly in the middle, so the motor would not need to move. But let's go ahead and adjust it slightly to see what will happen to the pulse width. Let's see if I can get them both at the same time here. Alright, if I push it down slightly, there we go. So what it's doing, as you can see, the top line is channel 1. It's going from 2.5 volts up to 5 volts. Now, as I push the servo down more, you can see you get more and more 5. That's what causes the motor to speed up and slow down as it approaches the center point. And then again, if you look at the bottom line, the blue one, that's channel 2, that's the output of the comparator. That one swings exactly from 0 to 12 volts. I have a larger power supply connected to the output so I can drive a large motor. Okay, now watch what happens when I push this thing the opposite direction. Yep, there we go. That's what it was. There's neutral, motor off, and go all the way to the other side. You can see that the square wave on the motor output is going from 2.5 to 0. So yeah, the further I go, it gets a little choppy there. But the further I go, the more ground you get. So once you get really far away from the center position, you get lots of ground, so that's what makes the motor go really fast in the opposite direction. But now notice the output of the comparator is 0 the entire time. It's like we don't even care when the output is below 2.5 volts. We don't care what it looks like because we just want the ground the entire time. Alright, so now let's see how this drives a motor. So let me put it back into the central position. Okay, neutralized. Also, I don't want to do this while the power is attached because, yeah, I couldn't monitor the output of the comparator at the same time as driving the H-bridge because the H-bridge drops the voltage significantly, so I wouldn't get a nice clean signal on the oscope. So what I'm going to do is I'll now attach the H-bridge to the comparator. I had it grounded just for monitoring purposes. So I'll just plug these from ground into the output of the comparator. So now let's go reattach power. And we will slowly move this. And there it goes. One direction full speed. Throttle back. Complete stop. No jitter. No vibration. Ice cold to the touch. Not even a heat sink on there. This is a 5 amp motor too. Alright, let's do that again. Here you can hear it buzzing. It's because it's receiving a square wave, so you can hear it. The humming is actually the frequency of the square wave it's receiving, which is, I believe I measured it, it's right around 50 hertz. Full open. Throttle back. complete stop. You can hear the buzzing completely goes away because all 4 transistors are off, and now they go the other way. Full open. Dead stop. Transistor check. Still ice cold. That's exactly how it should be. Alright. Hope you liked the demo. Peace. So here we are using the circuit in practice. Just wanted to give you a real quick demo of it actually being used. You can see on this rover I have servos mounted on all the legs. I removed the motors and am using them solely for positional feedback. So you can see that they have an input wire which is giving it the PWM signal, and the 2 wires coming out of it are the motor outputs going into this board. And then this board has all the H-bridges which drive these much larger motors, here, which actually controls the position of the legs. So you can see if I send it a command, I can go to exact positions because of these servos being externalized in this fashion.